Hey, I'm Jake, and in this video I'm going to do my best at explaining what resistance is. So essentially resistance is the opposition of current flow in a material under the influence of a potential difference. We have four materials. We have conductors, semiconductors, superconductors and insulators, each with different outcomes of resistance. But for the sake of time I'm just going to focus on conductors as they are the most easy to understand and the most common form of resistance. Since copper is one of the most widely used materials for conducting wires, here is my somewhat accurate representation of the atomic scale of a copper wire, which has raspberries representing the copper atoms or positive metal ions, and the blueberries representing the delocalized electrons. So in a metal lattice structure, we have the positive ions, which are essentially stationary, however they are actually oscillating back and forth due to the thermal energy of the surrounding environment, and what is known as a sea of free electrons that drift around randomly inside the lattice. It is important to note, however, that the net flow of these delocalized electrons is zero. To understand why these electrons are free to drift around, let's have a look at the single copper atom as well as energy bands. So copper has an atomic number of 29, which means there is 29 protons and 29 electrons. As can be seen, there is 2 electrons in the first shell, 8 in the second, 18 in the third, and only 1 in the fourth shell. This fourth shell is also known as the valence shell. Now looking over here at the energy band structure of conductors, we can see that the valence energy band and the conduction energy band, where the electrons become delocalized, actually overlap. This means that electrons can become free to flow even without an external supply of energy. So now that we know why electrons are free to flow randomly, we can see that when a potential difference is supplied, the net flow of the electrons begins to act in one direction, namely towards the positive terminal of the voltage source, due to the fact that opposite charges attract. However, when the electrons begin to flow, they start colliding with the positive ions. The kinetic energy of this collision is then transferred into thermal energy and released as heat through the conductor. This is the essence of resistance. Some factors that can influence resistance are summarized by the formula resistance equals material-specific resistivity times length divided by cross-sectional area. So in summary, resistance is caused by the collisions that delocalized electrons have with positive metal ions, and heat is released as a result of the energy transfer of these collisions. Furthermore, resistance is proportional to both the length of the conductor and the material-specific resistivity, and inversely proportional to the cross-sectional area of the conductor. Thanks for watching.